Hello all. Let us discuss problem number 2 for wind load calculations. In example 1, we have seen a case when slope of the building for wind was, or we can say upwind slope was less than 3 degrees. Now there are different combinations for slope greater than 3 degrees. So let us take another case using IS 875 part 3. Determine wind force on any intermediate frame of multi-story building. So multi-story building and any intermediate frame to be taken. Plot the wind pressure distribution diagram the same way we did along with the height of the building, and hence nodal forces at each floor level should be found out. So same way we did in previous problem, we have to do that, but only difference is what? Angle is greater than 3. Let us check. Length of the building is 48 meter, width is 40 meter, height is 34 meter. So building height is 34 meter. Story height is given as 3 meter. Frame spacing 4 meter in both the direction. So we can say bay width in both the direction as 4 meter. Location Chennai. Terrain category given as 2. Slope of ground 10 degree. Height of the hill 900 meter. Location from the crest is 200 meter. Crest is nothing but the apex point of any mountain or mountainous terrain. Design life period is given as 55 years. So these are the problem definition. We have to keep all these points in mind and we have to move forward. So it is quite simple. Let us see the plan. So in plan 4 meter bay width is given. Here I have cut the plan in both the directions. So we do understand that in lengthwise and in breadthwise or widthwise 4 meter bay width is given, and wind is acting like this in a length direction or in our length perpendicular to our length. Let us move forward. First thing is to be done is as step 1 and step 2, which is VZ and PZ. Let us see that. For design wind speed, we do what? For VZ or VD, we do K1, K2, K3 and K4 into VB, basic wind speed. So to find out basic wind speed, we have to turn the page of IS 875 2015 at 51, page number 51. Appendix A has a table for all the popular locations. From that, Chennai is having 50 meter per second basic wind speed. Now, let us find out K1, K2, K3 and K4. For K1, we have to see the table number 1, probability factor or risk coefficient. In table number 1, there is a mean probable life design period is given. From that we have to take 55 years. For 55 years there is nothing given. So we have to interpolate between 50 and 100. So for 50, the wind speed value is 50 and design life span is also 50, so it should be 1. And for 100 in the wind speed zone 50 meter per second, it is given as 1.08. So we have to interpolate the value between 50 and 100 years, that is for 55 years, and I am getting K1 as 1.01. So let us move further. K2. K2 table, we have to take it from table number 2, IS code, page number 8. We can see this table. According to our terrain category, we will choose the value for K2. Here, our building height is 34 meter. So I will take K2 up to 34 meter by interpolation, and 10 meter K2 is given for category 2 is 1, 1.05, 1.07, 1.12, and for above 30 that is 50 given. So I have to interpolate for 34 meter height. According to interpolation, it comes out as 1.30. So K2 is prepared. After that, I will go for K3. Now for K3, clause number 5.3.3.1 gives us some brief that the K3 is 1 when the angle is less than 3 degree. But here angle is given as 10 degrees. So it is also told that angle should be in a range of 1 to 1.36. But how much? For that we have to see appendix C, which is given on page number 54. On appendix C, you will find a formula for K3. K3 is equal to 1 plus C into S0. Now we have the 1 value, but the C and S0 are unknown. For C and S0, page number 54 suggests that for C, we should use formula 1.2 Z by LE. Now, for that, we have to find out Z and LE. So, in this figure, we can see Z and LE. Let us see here. When angle is between 3 to 17, it is shown in appendix C that LE should be L. LE is nothing, effective length should be the length. So here, if this is a crest is nothing a top. Now, this is a figure showing our building layout, or we can say mountainous region layout. Now, this is a crest and building is located somewhere here. So, angle is making as 10. So, my Z will be 900 meter and L will be like this. So, how to find Z and L? Let us see this. Now, 900 meters is given in the problem, as well as one more data is given in the problem is 10 degree. So, using both of them as well as this 200, I will get L is equal to Z by 10 theta, or by putting 10 theta here, Z by L, right? So L is equal to Z by 10 theta now. Z I have 900, theta I have 10. So putting both the values, I'll get L as 5104.15 meter. Now from L, or we can say LE, I would find out H, the height at which the building is located. So for that, I will put again 10 theta equation. Now 10 theta, 10 degrees will be like this, H upon LE minus 200. So one dimension is this H and another dimension is this. So I have to L minus this 200 length. So total L minus 200, which will give us this length. So height by length. So 10 degree is equal to H upon LE by minus 200. H will be found out as 864.73. Now I have H and L both as well as Z. So I can go for finding out C. C formula is given in appendix C only, that is 1.2 Z by LE. So putting Z and LE value, I will get C as 0.21. It is somewhat complicated, but it is simple if you practice once. Let us move to the next slide. Now we have to assume something. If it is hill and ridge or it is escarpment. So generally we will assume it as a hill and ridge. Now we will assume one more thing, which is downwind slope is greater than 3. So according to IS code, we will follow figure 13b, and from 13b and 14 we will find out these two images. Let us see how to use these images. Now I will find out H by LE and X by LE. I have H, X and LE all three. So H by LE comes out as 0.169, X by LE comes out as 0.039. Now as my structure is windward side, it is already given in the problem. Now, using H by LE and X by LE value, I will find out as 0. For S0, let us see how to find out this. Now I will check h by le and x by le values are in range of what. So I can see h by le and x by le is less than 1, both of them. So I will check the figure 14, and from that for h by le 0.169. So here x by le is shown, here h by le is shown. So x by le is 0.039. So I will move to 0.039. So 0.03 will be somewhere here, and h by le is 0.169, so it will be somewhere here. So checking both of them values, I will take s as lesser than zero point 0.8 is 0.7. Whenever you take any value from the graphs of any IS code, there might be variations in values by individual students. Some student take zero point 0.6 value, or some student can take zero point 0.7 value, some can take even 0.8 value, but it should be in a proper range, otherwise your marks will be cut. So let us move further. Here 0.7 S0 is taken. Now I can find out K3 as 1 plus C into S0. C is 0.21, S is 0.7, K3 I got is 1.147, and I will make it as a total figure as 1.15. So I have K1, K2 and K3. Now I will move for K4. For K4 it is very easy. Page number 8 and 9. K4 is given in 3 categories. For general all categories, K4 should be taken as 1. If your structure is an emergency structure or in a cyclone region or hospital or school structure like that important building, then K4 should be taken as 1.3, industrial building 1.15, otherwise all structures are instructed to take K4 as 1. Let us move forward. Now I will need KD, KA and KC. For that, for finding out KD is wind directionality factor. For KD, page number 9 and 10, clause number 7.2.1 suggests that KD should be taken as 0.90 if the building is a framework, and if the building is circular or nearly circular, you should take it as 1. So it is generally a framework, or we can say rectangular geometry of building. So we will take it as zero point 0.9. For KC, IS code clause 7.3.3.13 should be followed, and in that KC should be taken as 0.90. In previous video, I have also explained if a building is under the pressure of only from one direction only, then KC combination factor should be taken as 0.9. But if in case it is given that the wind is acting from two directions in a different direction, then you should take KC as 1 for safety. And a third factor, that is Ka. Ka is area averaging factor, and for area averaging factor we need tributary area. Tributary area is what? It is nothing but the distance from column to column and beam to beam, center to center. So 2 plus 2 into 2 plus 2, half of the column to column, half of the column to column, and half of the beam to beam, and half of the beam to beam should be multiplied. So 4 into 4 comes out as 16 meter square. Now I have table number 4 and clause number 7.2.2 in IS code have values of less than 10, 25 and greater than 100. So I have to interpolate my values here as it is a 16 meter square tributary area. So I have the value for 10 or less than 10, it is 1. For 25 it is 0.9. So my value should be between 1 and 0.9. According to interpolation, If the gap is of 15, the gap is of zero point 0.1. So gap is of like 6, then what is the gap? So from cross multiplication, I will get my Ka as 0.96. Now I have Kd, Kc and Ka. So you should remember one thing always, Kd into Ka into Kc should be minimum zero point 0.7. So here I am putting Kd zero point 0.9, Kc zero point 0.9 and Ka 0.96. I am getting Kd into Ka into Kc as 1, which is greater than zero point 0.7, so it is okay. Otherwise, if the value is below zero point 0.7, you have to take at least zero point 0.7 value. Moving forward to the table. Here in this table, wind pressure and wind speed as we calculate regularly, we have to make a table. But from previous problem, it is somewhat different due to the height variations. Here 5 rows, 10 meter, 15 meter, 20, 20, 30 and 34 should be taken. One more thing you should understand, that is hill and ridge and cliff and escarpment. In IS 875 there are two different figures. Hill and ridge is a 3D kind of, in 3 dimensions there is a mountain, it is hill and ridge. If there is a mountain in 2 dimensions, it is generally known as cliff or escarpment. Now, for cliff and escarpment, generally downwind slope is considered as less than 3. For hill and ridge, it is considered as greater than 3, as it is in a 3 dimensional area. Now, let us focus on the table again. I have different heights. I have VB for all the heights because it is in Chennai, in the same region. VB will be constant through the table. K1 value will be constant throughout the table, 1.01. K2 will change according to IS code values we have calculated previously. K2 has been written. K3 will be constant 1.15, which is found out. K4 will be constant 1. Now, to find out Vz or Vd, which is design wind velocity, I will multiply second column, third column, fourth column, fifth column and sixth column. I mean Vz is equal to Vb into K1 into K2 into K3 and K4. So all the values of Vz will be different due to this difference in K2. So I have different values of wind velocity. From that I will find out Pz, which is zero point 0.6 into Vz square. Now the values are like this. And from that I will find out Pd value. Pd is nothing but Kd into Ka into Kc into Pz. So I have got Pz from zero point 0.6 Vz square. I have got KD, KA and KC, so I can find out that. Here I have taken KD value as 0.90, KC value as 0.90 and KA value as 0.96. All three values of KD, KA and KC will be constant throughout this table, but PZ value will be changed in all rows. That is why the value is changed in all rows. Here I have got for 10 meter PD design wind pressure as 5073.56, for 15 meter height 1734.93, 20 meter height 1801.56, for 30 meter height 1974.25, and for 34 meter height it will be 2009 Newton per meter square. So here my step number 1 and 2 are over. After that we will go into step number 3, design wind load. So that's it for this session. We will learn this problem, this second half of the problem in the next video. Thank you.